Hello viewers, today we are going to see about basic RTL NOR gate. RTL means resistor transistor logic. So if you see the circuit diagram, you can see three transistors, say Q1, Q2, Q3, all are same similar transistors, and then you can see the resistors. So we have resistors and transistors. Only we have resistors and transistors, not anything else. Okay. Now, so this is the circuit diagram to realize a NOR gate. We will see how it works. So the output is taken from this point, which is equal to y is equal to a plus b plus c, a or b or c whole bar. First we will assume that a, b, c as 0, 0, 0. For OR operation, we all know that 0 plus 0 or b 0 or 0, which is 0. But for NOR, it will become 1. So first we will see how we are getting this 1. Okay. Here, if I say 0, 0, 0 means, here it is 0 volts, B is also given 0 volts and C is also given 0 volts. Since all the three inputs are 0, there is no base current. So the all the three transistors will not go into conduction. Therefore, the transistor will be in cutoff. So if that is the case, VCE, collector to emitter voltage, is equal to VCC. That means between emitter and collector you can see 5 volts. So we are taking the output between emitter and collector. So if you connect a voltmeter, you can see 5 volts. So 5 volts is equal to logic 1. That's why we put 1. So next 0, 0, 1. That means A and B is grounded or 0 volts, whereas C is given at 5 volts. So when you give 5 volts, these two transistors are cut off. Whereas since the third transistor is given 5 volts, this transistor goes into conduction. So when I say it goes into conduction, it acts as a short. That means between collector and emitter, you can see that it is a short circuit. Or VCE is approximately equal to 0. Accurately it will be 0.3. But anyhow, it is going to be logic 0 only. So since C is given plus 5 volts, this transistor goes into conduction, whereas the other two will be in cutoff. So this will act as a short. If I say short, this 0 comes, because it is short, this 0 will appear here. So the output here is 0. Okay. But for OR operation, 0 plus 0 plus 1 is 1. 1 inversion, it is 0, the NOR table. Okay. So this is one case. Next case, 0, 1, 0. Here, this A input and C input is grounded 0 volts, whereas B is given 5 volts. So if I give 5 volts, this goes into short circuit, whereas these two are in open. Since this goes into short circuit, this 0 will come, the collector to emitter voltage is approximately 0. That means you can view this as collector to emitter as a short. So this 0 will appear here. So the output here will be 0. Okay. Likewise, you can check out for 0, 1, 0, 0, 1, 1. B and C is given plus 5 plus 5. Therefore, both the transistor goes into conduction. Therefore, collector to emitter is 0 volts. It acts as a short. This is also act as a short, whereas this one is open. So, two short circuits parallel, but this 0 will come here because it's shorted, or for the transistor 3 also it will be the same. So, this 0 will come here. So, for this case also 0. Likewise, if you keep on going, and when the input, assume that you can test for all other cases also, when the input is all or 1. All are 0 we have seen, and the combinations also in between also you can test it out. So when all are 1, 5 volts, 5 volts, 5 volts is given here. All the 3 transistors will go into conduction. So that means collective to emitter you can view as a short, short, short. Therefore this 0 will come because it's a short, it will appear here. So for all are 1, it is 0. So this is the truth. So I have not completed other 3 states. You can try it out, you will get the same answer. What you have to keep in mind is when you give a 5 volts, base current is there, therefore collector current, and the transistor is driven into saturation. If it goes into saturation, Vc is approximately 0. Therefore, you can view the collector to emitter as a short, so that 0 will appear. So this is the basic RTL NOR gate, the functioning of the basic RTL NOR gate. I have explained in detail. Hope you have understood the concept behind RTL NOR gate. Thanks for watching this video. Nandri.